A very warm good evening to everyone. I, Aiden Rennie, will be your moderator for today's session, Machine Learning, organized by Vidya Dan. From self-driving cars to Gmails, spam mails, and filters, almost every electronic gadget we use today has some form of AI involved in this working. In today's session, we have Raghavendra Sharma with us, who is currently studying in grade 11 in GEMS International School, Dubai. He has many accolades to his credit. To name a few, he has won a gold medal for UAE at the International Robot Maker Competition. Along with that, he has participated in the first Lego League, World Robotics Olympiad, and the World Scholars Cup. He has completed a 3-month internship, which was jointly hosted by Nanyang Technological University, Singapore, and Hewlett Packard. Pursuing his passion in computer science, he has completed courses in CSS, Java, HTML, Python, C++, and 3D modeling. He has also completed courses in Prepar 3D V4, Flight Simulator, and Drone Dynamics. So, before we dive into the presentation, Raghavendra, I have a few questions. I hope that's fine with you.
Yeah. Sorry.
So, first of all, when was it that first you noticed you had a little bit of interest in machines, robots, or in a general way to say it, AI?
Hello everyone. Thank you for that introduction. To your question, that program taught me and that program robots from Legos.
You are quite lagging. Could you please repeat that?
Sorry. So a couple of years back, my dad enrolled me in a summer course about robotics that taught me how to make small robots from Legos. That noticed my passion for robotics, and from then onwards, I've been about coding, AI, and stuff.
Okay, great. Next question. For those who don't know actually what these proper definition of what AI is, could you please define it?
So AI, you cannot AI, but it is to make a machine like a human being. It also be called the study of how the human brain thinks, works, learns, and decides to solve problems. And AI has many subsectors. It can be divided into many subsectors. And today we're going to be focusing on one of the most important subsector called machine learning.
Okay, great to hear. So without any further delays, why don't we just dive right into the presentation?
Sure.
Great.
Just a minute. Share my screen.
Yep, stage is all yours.
Can you see my screen?
Just a moment. Yeah, perfect.
Okay. So as we all know, cells are just how cells are the building blocks of life. Machine learning is the building block of AI. So what exactly is machine learning? Well, machine learning is the technology that is used to train machines to perform various actions that require recommendations or estimates, as Aiden had previously mentioned, from your YouTube recommendation to self-driving cars. Almost everything today involves machine learning. The infographic that I have used on my screen. This infographic is an accurate representation of machine learning. So it is where you teach a system or a model to think like a human brain. So machine learning has 3 key aspects. It has task, experience, and performance. Task is the problem that we are interested in solving through machine learning. So let's take an example. You want to build an app that it's quite a basic example, but just for the sake of explanation, you want to build an app that can differentiate between sorry. For this one, we can take YouTube as an example, YouTube or Instagram. So the task is to keep you on their platform for as long as possible. Experience. So it is learning from past data or historical data to resolve future problems or to give a good estimate. So YouTube and Instagram, they track for how long you stay on a video or for how long you stay on a post and the type of posts or videos you like. That is the experience that you're giving to the AI that is specifically dedicated for you as a user. Performance. So performance would be the capacity or the ability of the machine to resolve the task by providing the best possible solution. In the same example, the performance of this AI model would be how long it is able to keep you stuck to that Instagram or YouTube. Now Instagram and YouTube, the reason they do this is because they can show more ads and get more wealth. Now, in experience, we have seen that uh, the model learns from past or historical data that's used. So for this, we select a model or data set to train our AI, and we distinguish into two parts, which one is seen data and the other one is unseen data. So the scene data set is divided into two again. One is the training set and one is the validation set. The training set is basically where the AI learns and it trains. The validation is where it self checks itself. And then you have the unseen data, wherein us humans, we test the AI. So once the model has been chosen, it is trained and validated on the entire or the seen data set, and it is tested on the unseen data set. Next, we have techniques in machine learning. There are four main techniques in machine learning: supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. Today, we'll be going over the first three, that is supervised learning, unsupervised learning, and reinforcement learning. So supervised learning. It is applicable when a machine has sample data, that is input as well as output data with correct labels. So let's say you're trying to build an app that can differentiate between produce. So it can differentiate between apples and bananas. So you will take images of apple, you will tag them that this is an apple, and you give the AI that this is an apple and this is a banana. So you upload a couple thousand pictures of apples and bananas, and that is called supervised learning. Unsupervised learning is when you just take pictures of apples and bananas and you give them to the AI. Now the AI is like a newborn baby. It has no idea what it's doing. So what it does, it classifies the apples and bananas based on how it thinks they should be classified. So it can classify them based on their colors, wherein green apples, red apples, and yellow bananas are different sets. Or it can classify them based on their sizes, wherein an apple has a more spherical shape and a banana has an elongated shape. Sorry. Yeah. Or it may even classify them based on their sizes. Reinforcement learning. Reinforcement learning is a feedback-based machine learning technique. So the AI, again, just like in unsupervised learning, it starts off as a child. It performs an action, and there will be a human interpreter that sees that oversees the action. If the action is good or helpful, the AI will get a reward. And if it's not a helpful action, the AI will get a punishment or a negative reward. Semi-supervised learning, it is an intermediate technique of both supervised and unsupervised learning. So you have pictures. So going back to the original example, you have pictures of apples and bananas. You will tag some pictures of apples and some pictures of bananas, and rest are untagged. So this has the advantages of both supervised and unsupervised learning. But semi-supervised learning is not the focus of today's session. Now, let's dive deeper into supervised learning. So for supervised learning, most of the times there is a graph, and there is a line of best fit between the x and the y-axis. And as we all know, the equation for a line is y is equal to mx plus b or c. but in this case, it is y is equal to mx plus b plus this quirky looking 3. What this 3 is, basically, it is the error. We don't need to quite focus on this as of now. The b over here, as we know, is the y-intercept, and the m, but the m is not the gradient of the x-axis, it is the coefficient of linear regression. So let's take an example over here. Over here, there are red dots on one side and blue dots on the other side. When the coefficient regression coefficient was 0, the line that was drawn has perfectly separated the blue dots from the red dots. When the coefficient of linear regression was 1, one circle or one red dot was being cut out, as you can see over here. So this cannot be called a line of best fit. When the gradient was taken as -1, there were 2 red dots that were being cut out. So we usually take the coefficient of linear regression that is the best for us, and this is usually found out through trial and error basis. One of the first applications of supervised learning was handwriting recognition, handwriting recognition. It was one of the first commercial and widely used machine learning systems. And let's say to train the AI, you take a data set of 6,000 examples of each digit. So this gives you a testing error of 0.4%, which is an amazing testing error, because most AI present today have a testing error of about 5 to 10%. This in modern terms is also called natural language processing. And here are examples of numbers as digits. So you have zeros in all possible ways they can be written. You have number 1, you have number 2. So the more data you give the AI to train, the more accurate the AI will be. Next, we move on to unsupervised learning. Unsupervised learning has 3 main goals: clustering, dimension reduction, and correlation. Clustering is learning meaningful groupings of the data. So again, like I stated before, it may in the bananas and apples example, it may classify them based on their color, their shape, their sizes. Dimension reduction is dimension reduction. So let's say there is a graph that is drawn in the 3D axis. Now, most laymen won't be able to understand this graph or interpret it accurately. Therefore, it is cut down to a 2D shape. Now, if us humans sit and try to do this would take us quite a lot of time. Whereas AI has proved to do this efficiently and with minimal data loss. Correlation is learning meaningful relationships between variables or units. Now let's look at examples for each of these to make it easier to understand. So for the first one, we have clustering. So as you can see over here, there are circles, there are triangles and squares that have been clustered. We have dimension reduction. So over here, as you can see, it was a 3D graph that is not quite possible to understand. So they have taken the top view of the graph and they have expressed it. So this graph shows us minimal data loss, and it is quite easy to understand. Now we look at correlation. There are quite a few types of correlation. So you have the positive correlation, wherein the gradient is positive. You have a negative correlation wherein the gradient is negative, and you have no correlation wherein the line of best fit is a horizontal line passing through the x-axis, going towards infinity. We have a stronger correlation wherein all the points lie within close proximity of the line of best fit, and we have weaker correlation wherein the points lie further from the line of best fit. Then correlations don't always have to be linear. They can be in the shape of a parabola, as you can see over here, or they don't necessarily have to be a defined shape. It can be logarithmic, cubic, quadratic, anything. Now let's look at reinforcement learning. Um, so an agent takes an action in the environment. In the environment is basically like the place where the agent is taking the action, and this is overseen by an interpreter or a human interpreter, that is us, who then rewards or punishes the system. Now, reward and punishment doesn't quite literally mean rewarding or punishment. A reward would be a positive number, and punishment would be a negative. So with this, this diagram is a good illustration of how this works. So we have the agent or the AI over here, which takes an action in the environment. So let's say this is a maze wherein wherein a person has to move from point A to point B in a 3D simulation. So for every correct move the agent makes, the interpreter gives the agent a reward, and if the move is incorrect, the interpreter gives the agent a punishment or a negative number. Now let's have a look at how at the how the coefficient of regression helps. So let's say over here in this example, we can see that the line of best fit has the points lie within a large proximity of the line of best fit. Now this graph is called underfitting because as we can clearly see, the line of best fit would not just be a straight line. Then over here in this example, we can see that the line of best fit is quite it tries and goes through every single point. Over here we get a really low error, but this is not necessarily what we want, because we want an average reading of all of them. We don't want like a perfect reading, because then it would be really hard for the AI to make future predictions, and the future predictions will be quite inaccurate. Over here, this is just right. So we have the line of best fit looking like a parabola, and the error is way lower than the underfitting graph, and higher than the overfitting graph. This gives us more accurate predictions for the future. Then we have classification, wherein the red dots have to be separated from the blue dots. Now, underfitting in this case, as you can see over here, the red dots on the red dots have so many blue dots present in their area. So this would be called underfitting. Overfitting would be where there is zero tolerance in this case, as you can see. So they made sure the red points, the red dots were in the area of the red dots, and the blue dots were where they're supposed to be. But just right, as you can see over here, there's bare minimal error. So there's just two blue dots that are present over in the red dots area. Deep learning this deep learning part is not quite required for us. So how do you solve if the graph is underfitting? So you complexify the model. You can add more features. You can increase the coefficient of regression. And if the model is overfitting, you can regularize the model, or you can give the AI more data to train itself, and you can reduce the coefficient of regression. Now let's have a look at neural networks. So neural networks is basically what's present in our brain and our nervous system. So we have nerves connecting from one to another that pass on the electrical signal or transmit the electrical signal from one to another. But how is this related to our topic? Well, there's something called the artificial neural networks that is now widely used. So they're a class of models that are built with layers, and they can be divided into conventional and recurrent neural networks. So you have the hidden layer, so you have the input layer, and then you have a few hidden layers. Now each input layer is connected to one hidden layer, and that hidden layer is connected to another set of hidden layers, all the way until it reaches the output layer. Now, why is this so useful? Is because this is the graph that shows us as the amount of data that we have increases, larger neural networks are able to give us better performance, whereas traditional learning algorithms like the ones I showed you before, such as reinforcement learning, they don't give us so much performance, and the performance, it just stops increasing after a certain point. Whereas for larger neural networks, it doesn't slow down as much. Next, we look at bias and variance trade-off. Bias is the bias difference between the expected prediction and the model that we predict for the given data points. So in other words, this can be called the accuracy of the model. Variance of a model is the variability of the model for the prediction for the given data points. So in other words, this can be called the uncertainty of the data points. And bias and variance trade-off. So the simpler the model, the higher the bias, and the more complex the model, the higher the variance. Now, but why are we looking at bias variance trade-off? An algorithm can't be more complex and less complex at the same time. To build a good model, we need to find a good balance between the bias and variance, such that it minimizes the total error. Looking at this graph, the bias and the variance both of them create an asymptote, and then the total error is then reduced from this graph. The wider the lines, the greater the distance between the two lines of this parabola, the lesser the total error, and the greater the total error, and the lesser the distance between these lines, the lesser the total error is. So we want this parabola to be as small as possible, so that the error is minimum. Now let's look at a video. This, as I'd explained before, reinforcement learning. This is a great example. This video will show us a great example of reinforcement learning that was built by Google. So basically, this video shows us how an AI developed by Google taught itself how to walk. Just a second, let me see if I'm sharing my sound. So as we can see over here, this walk might look goofy, but all the programmers at Google did was they told this AI to move from point A to point B with obstacles in the middle, and this AI has practically taught itself how to walk. So if the AI fell down while climbing over the obstacles, that then it would be given a punishment or a negative number. If the AI successfully jumped over the obstacles, then it would be given a positive number. This walk looks, I know it looks kind of goofy, but this is what an AI has taught itself. This walk looks kind of goofy, but as they had previously just shown, the AI was just told to move from point A to point B. Is when the AI AI falls down, this is where the interpreters come in and they give the AI a negative number or a punishment. So this reinforcement learning is quite literally the example of how mistakes make a person stronger or how they help a person to learn. Thank you so much. Thank you so much for paying attention. And do you have any questions?
I think they have very much understood everything because I don't see any questions. So thank you, Raghavendra. I think everybody would agree that that was such a wonderful and informative presentation. And with that, we have reached the end of the session. I hope you all enjoyed it. If you would like to share your interests and ideas, please do reach out to Vidyadan. I would like to thank Vidyadan especially for giving me this prestigious opportunity to become the moderator of this session. Please do like, share, and subscribe so that you do get notified when we drop out more and more informative videos just like this one. Thank you all and hope you had a great day.